Welcome guys, in this video I will be solving this particular question from the chapter Gravitation from Physics. The question says, two spherical stars A and B have densities rho A and rho B respectively. A and B have same radius and their masses MA and MB are related by the equation MB is equal to 2 times of MA. Due to an interaction process, star A loses some of its mass so that its radius is halved, while its spherical shape is retained and its density remains rho A. The entire mass lost by A is deposited as a thick spherical shell on B with the density of the shell being rho A. If VA and BB are the escape velocities from A and B after the interaction process, then the ratio of VB by VA is equal to under root of 10 into n divided by 15 to the power of 1 by 3. Then the value of n is. This is the question. Let's see the solution. Initially, they have given that star A and star B. Let's assume this as a perfect sphere and it is with a radius of r, so that the mass of star A equal to m and the mass of star B equal to 2m. Since the radius is same, let's say the volume of both the stars are equal. They have given that density of star A is equal to rho A and density of star B is equal to rho B, which is equal to 2 rho A, because mass is equal to volume into density. Is it so? Which means mass is directly proportional to density. Let's say rho A by rho B is equal to m divided by 2m, which means rho B is equal to 2 rho A. This is the stuff I have written here. Okay. Now finally they have said that due to the interaction process, the star A loses some of its mass so that the star B gains it as an outer shell or layer. Okay, so because of losing the mass, the star A radius becomes r by 2, reduces to r by 2, so that the volume changes to V is equal to 4 by 3 pi into r cube by 8. New mass of the star A is equal to m by 8. Let's solve it so that new mass is equal to density into new volume. Is it so? Let's say at initial position mass is equal to volume into density. They have given that mass as an m, so that for this star density is given as rho A and volume as 4 by 3 into pi r cube. Is it so? Now for this new mass m dash is equal to, they have said that mass is lost by star A and the radius of the star is reduces to r by 2, but it regains its spherical shape and density, so that density remains same but volume changes as 4 by 3 into pi r cube by 8. Yes, now let's separate this term so that m dash is equal to m by 8. This is the value I have written here. Okay, now I am going to find out the lost mass of star A and the gained mass of star B. Okay, now I am going to find out the new mass of star B by using conservation of mass. Let's say mass lost by star A equal to mass gained by star B. Is it so? Now let's say initial mass of star A equal to m. Yes, and final mass of star A equal to m by 8. Now with the help of this data we could find that what is the lost mass of star A. Let's do the subtraction now. M minus m by 8, which is equal to 7m by 8, which is the lost mass of star A, and this is the mass gained by the star B from star A. Therefore initial mass of star B equal to m, and then gained mass of star B 7m by 8. Let's find new mass of star B 2m plus 7m by 8. Now 23 by 8 into m, which is the new mass of star B. Now to find the ratio of escape velocities, we need to find the unknown radius of star B. Let's use conservation of volume. Volume lost by star A is equal to volume gained by star B. First, let's start with the volume lost by star A. To find the volume lost by star A, we need to find the difference between initial and final volumes of star A, because the initial volume is greater than the final volume, because the volume is lost by star A, which means initial minus final. So what will be the initial volume? 4 by 3 pi r cube minus what will be the final volume? 4 by 3 pi r cube by 8, and volume gained by the star B, which means volume is increasing. So that to find the volume gained by star B, we need to find the difference between the final volume and the initial volume. Make sure to understand this point. For volume lost by star A, we need to find the difference between initial volume and final volume, because the volume is decreasing, and to find the volume gained by star B, we need to find the difference between final volume and initial volume, because the volume is increasing. Now what will be the final volume of star B? 4 by 3 pi, the new radius is r dash the whole cube, minus what will be the initial volume of star B? 4 by 3 pi r cube. That's all. Let's get rid of 4 by 3 pi and 4 by 3 pi on both the sides, so that we will be getting r cube minus r cube by 8 equal to r dash cube minus r cube. So r dash cube is equal to 2r cube minus r cube by 8, which implies r dash cube is equal to 15r cube by 8. R dash is equal to 15 to the power of 1 by 3 into r divided by 2. Yes, this is the value of r dash, the new radius of star B. Let's find the escape velocities. What is the general formula for escape velocity? V is equal to g into mass divided by r. Yes, now let's find the escape velocity for star B, which is equal to under root of g into what is the new mass of star B? 23 into m divided by 8. And what is the new radius of star B? Which means r dash equal to 15 to the power of 1 by 3 into r divided by 2. Yes, this is the escape velocity for star B. Let's find escape velocity for star A. VA is equal to under root of g into what is the new mass of star A? M by 8. What is the new radius of star A? Which is r by 2. This is the escape velocity of star A. Now the question they are asking is, we need to find the ratio of VB by VA, which is equal to under root of, let's take a big root, g into 23 into m divided by 8 into 15 to the power 1 by 3 into r by 2 into r by 2 into g into m by 8. So let's get rid of g, 8, m, r by 2, r by 2. So VB by VA is equal to under root of 23 divided by 15 to the power of 1 by 3. In the question, they have given that VB by VA is equal to under root of 10 into n divided by 15 to the power of 1 by 3. Now, if we separate 10 from this value, we will be getting VB by VA is equal to under root of 2.3 into 10 divided by 15 to the power of 1 by 3. Therefore, the value of n is equal to 2.3. This is the final answer. The value of n is 2.3, which is the correct answer. Thank you.